Welcome to Geometry Virtual Learning, your online tutor. This lesson 3 is about trigonometry and Pythagoras in 3D. So I'll recommend that if you haven't watched my previous lessons on trigonometry and Pythagoras, I do recommend that you go back and watch before this lesson. And I welcome all new viewers. I hope you're going to stay along with us and share our videos with your friends. So in this lesson, we'll be talking about sine, cosine, and tangent in 3D, and also use Pythagoras to help work out missing sides and angles. And we'll of course talk about exam style questions. In our first example, we have a cuboid with dimension 8 by 6 by 5. We're supposed to work out angle X as you see in the diagram. The first thing that I want you to notice is that triangle EGB is a right angle triangle. So all you need is two sides of it and you'll be able to work out angle X. One thing you need to know is that EG is 5 cm, which is the same as the height. So with EG given, you either work out the longest diagonal, which is EB, using Pythagoras, or the shortest diagonal, GB. So it's a matter of choice what you want to do. So I'm going to work out either from there you use trigonometry to work out angle X. I'm going to work out GB. So looking at triangle BGH, you could see this is a diagonal or the hypotenuse, and this side is 6 and this side is 8. So GB is equal to the square root of a squared plus 6 squared, and that gives me 10. So I know this side to be 10. So looking at EGB, I have 5, 10, and the interior angle X. So let's pull it aside. So this is what I have. So I have a simple trigonometry question as we did in lesson 2 on trigonometry. You label opposite, adjacent, that means a tangent formula. We cover the tangent. So because it's the angle, we're going to work out the inverse of tangent of opposite divided by the adjacent. Then your calculator will do the work for you. Second function, tangent. You see the tan -1 with the bracket open. Fraction button, 5 at the top. Use the cursor, bring it down. 10 at the bottom. Use the cursor, move it to the right, close the bracket, hit equal sign, and that will be your answer. Second example, a shape below is a triangular prism. Point G is a midpoint of FD. Point A is the vertex of the face ABC, which is a equilateral triangle. Find the angle between the line AG and the plane BCD. Answer in 1 decimal place. Okay. This is exactly what they want to work out, angle X. Now, let me explain a little bit here. Angle between a line and a plane. What does it mean? The line, every point on the line should form right angle with the plane. So that's how you know where the line will be. Because every point on the line should make right angle. Every point. So that's why it has to be this line. So when they ask you a question, a line and a plane, that line, every point on it, imagine a point on it making right angle, you'll be able to know the triangle that you're supposed to draw. Okay, now let's start. We need only two sides and we'll be able to work out angle X. CD is 12, so therefore HG is also 12 because they are the same. We can either work out AG or AH. It's a matter of choice. What you can work out is what you do. It's easier for me to work out AH because if I look at it carefully, that's right angle triangle, and it says ABC is equilateral, so all the sides 8, 8, 8, and half of 8 is 4, and this side is 8. So AH is equal to square root of a squared minus 4/2. Remember, I'm not looking for the longest side, so I'm using the subtraction rule. And AH is 4√3. That's what I have. So let's pull AHG aside. Okay, so now we have the right angle here. We can label our work opposite, adjacent. That means we need the tangent formula, we are looking for x, so the tangent that we cover, and because it's the angle, we're looking for the inverse of tangent, opposite over adjacent. O is 4 root 3, A is 12, so tangent -1 of 4 root 3 over 12, and the calculator works out as 33.30. And this is a typical exam style question. Okay. The diagram shows a pyramid. The base of the pyramid BCD is a square. Point O is the center of the square. BC equals 12. The angle between AB and the plane BCD equals 65. Calculate the volume of the pyramid. Okay. First, we know BC is 12, so it's a square, so 12, 12 all around for the base. And also the formula for a pyramid we know as area of the base, which is 12 times 12, then times the height, then we divide by 3. So we need to first work out the height, and we'll be able to work out the formula, the volume of the pyramid. Now, the first thing you need to do is they set the angle between line AB, this line AB, and like I said, line AB, every point should make right angle. Every point should make right angle. So that's why it has to be the diagonal line here. So having noticed this, we know AOB is its right angle triangle. So if I'm able to work out BO with this angle 65, I'll be able to work out the height. And to work out BO, I need to work out BD. So looking at it carefully, let's focus on BDC. That is hypotenuse of a right angle triangle. So using Pythagoras, BD squared is 12 squared plus 12 squared. And using the calculator, BD squared is root of 12 squared plus 12 squared. And that gives us 12 root 2. So I know BD as 12 root 2. Now, I need to work out BO, so that I can use BOA to help me work out the height. So let's look at ABO. ABO, that's a right angle triangle. I want to work out the height, which I call it X. I know BO is half of BD, so half of 12 root 2 is 6 root 2. So let's put ABO aside. So this is what we have. We can now label opposite, adjacent. We need a tangent, triangular formula. So tangent. We are looking for X, which is the O. We cover O. That means we're supposed to divide the adjacent side over the tangent of 65. So X equals A over tangent of 65. And replace A with 6 root 2. So X is 6 root 2 over tan 65. And we have X to be 5.1977 continuous. So we know the X is approximately 5.2. Now, knowing our height, we can now work out the volume of the pyramid. The volume of the pyramid, as I said before, is the area of the base times the height. The height from previous slide is 5.197. The base area, which is 12 times 12, is what? 144. Substituting height and the base into the formula, we have 144 times 5, 51.977. So 144 times 5.1997 all over 3. And that gives us 249.6 centimeter cube. 249.6 centimeter cube. And that brings us to the end of lesson 3, combination of Pythagoras and trigonometry in 3D. Hope you've enjoyed the lesson. Please share with your friends and subscribe to this channel. Hit the notification button so you'll be alerted to all my videos. Thank you very much for watching.